Hi, in this video, I'm going to be working out some examples from chapter 4.1, which is mainly focused on translations. Okay, so like shifting an image left, right, up, down within the coordinate plane. All right, so in the first three questions, we have some vectors here, right? So a vector is a representation of both the direction and magnitude we want to shift or translate an object. Okay. So we're going to be naming these vectors. So this is vector mn, right? This is the starting point, and this is the ending point. Okay, so let's write mn. And then the symbol for a vector, it's like, it almost looks like an arrow, except we only draw one tick of the arrowhead instead of both ticks. Okay. Here, B is the starting point, A is the ending point. So we would call this vector BA, and this is JK. Sorry, KJ. KJ. All right, now every vector can be broken down into a horizontal and a vertical component. I'm going to color code these. Okay. So for the first vector, the horizontal component would be what, four units to the right, and the vertical component would be 1, 2, 3, 4, 5, 6 units up. Okay. And so we would write that kind of like an ordered pair, right? So it'd be 4, 6. Okay. But instead of using parentheses, we use these symbols instead. I'm not quite sure what they're called, but this is the vector's components: 4 in the horizontal direction and +6 in the vertical direction. When you're drawing the components, you have to make sure that you always start at the starting point or the initial point, and you always want to do the horizontal component first. So for problem 2, right, the horizontal component would be what, 1, 2, 3, 4, 5 units backwards to the left, right? So we would count that as -5 horizontal component. And then you'd have to add on the vertical component, because we're going down, that will also be negative as well. Okay, so -5, -1. I should probably put an equal sign there. Are the components of this. -5 is the horizontal component, and -1 is the vertical component. Okay. And our last vector, again, we're going to do the horizontal component first, always start at the starting point. Okay. So that's 1, 2, 3, 4, 5 units, again, -5, because we're going to the left, we're going backwards. But then the vertical component is +3. Okay, so we write -5 and then +3. Okay, that's the component form. All right. Next, let's perform some translations. Okay, so we're going to start with a pre-image of a triangle. Okay, so that symbol lets us know it's a triangle, and the points or the vertices of the triangle are going to be labeled ABC, and we have their coordinates here. Okay, so point A is at 1, 2. 1, 2. B, so let's put A there. B is at 5, 1. And C is at 5, 4. Okay, so let's use a straight edge. Okay. So there is our triangle. We call that the pre-image. Okay, and then we're going to use these vectors in their component form to now shift or translate the triangle. Okay, so this is saying, okay, let's move every point on that triangle 4 units to the left, right, because that's a horizontal component, and then we're not going to do any vertical component. All right. So one way that we can do this is I'm going to use this is called patty paper, right, to trace my pre-image. Okay, hopefully this shows up okay on video. Okay, all right. And so starting in its original position, let's go ahead and perform this translation. So we're going to go -4 in the horizontal direction. Okay, so I'm going to count it 1, 2, 3, 4. Okay, and so now I can see kind of in the background, right, the original image or the pre-image, and then on my tracing paper, right, this is my tracing paper, is the new image, right? It's 4 units to the left. Okay, and if I was going to label this new image, this would be A prime, B prime, and C prime. Okay, I'm not going to do the labeling here. I just want to show you the translations, the shifts. Okay, let's reset. And this one says -2 for the horizontal component. So that's 1, 2. And then that says -4 for the vertical component. So 1, 2, 3, and 4. Okay, and so that would be the new image there. Okay. All right, we'll reset again. Okay, for the next one, the horizontal component is 0, so we're not going to shift left or right, but the vertical component's -5, so we'll drop this down 5 units. 1, 2, 3, 4, and 5. Okay, and that would be the new image. Okay. And then we'll reset one final time, and then we're going to do 1 unit in the horizontal direction, so that's to the right 1, and then -3 for the vertical component, so drop down 1, then 2, then 3. Okay, and so that's our new image there. All right. So this is very handy. This is called patty paper or tracing paper. All right, let's see, question 8 and 9. Okay, write a rule for the translation of quadrilateral PQRS to quadrilateral P prime Q prime R prime S prime. Okay. Well, to determine the rule, we need to first find a vector, okay, from an original point to a new point. Okay. And so here I'll just go from point P to point P prime. Okay. So that's the vector. Okay, it's going up and to the right. Okay. And then I want to break that vector up into its components. Okay, so the horizontal component is 4, right? Because we're going to the right in the positive direction. The vertical component is 3 because we are going up 3 units. Okay, so a rule could be something like, so here's what a rule looks like, right? It starts with some generic coordinates, x and y, and then there's a rule for how much to add to the x coordinate and how much to add or subtract from the y coordinate, okay? The amount we add or subtract is basically these horizontal and vertical components, okay? So my rule here is gonna say, all right, take any ordered pair x, y, and then we're gonna add 4 to the x coordinate, right, which is the horizontal position. So write x, use color here, plus 4. And then for the y coordinate, we need to add 3. So the rule would be y plus 3. Okay. So it's really 2 rules. It's a rule for how to adjust the x coordinate, and it's a rule for how to change the y coordinate. All right, let's look at problem number 9. Okay. Again, we need to draw a vector from an original point to a new point. So I'm going to go from Q to Q prime. All right, so that's my vector. And now I'm going to break it up into its components. So always do the horizontal component first, right? So that's going to be +1. And then our vertical component is going to be -3. Okay. So as a rule, right, the x coordinate is going to increase by 1. The y coordinate is going to decrease by 3. So we'll write x comma y, just a generic point, generic coordinates. But then the x coordinate will increase by 1. Right? That's our horizontal component. And then the y coordinate is going to decrease by 3. Right? And that's related to the vertical component of our vector. All right, so now what we'll do is we'll apply a rule to a point. Okay, so the rule says add 6 to the x coordinate and subtract 3 from the y coordinate. Okay, so I'm going to add 6 to 4 and subtract 3 from 5. And what I would get is I would get 10, 2. Okay, that would be the new position, the new location of that point. All right, we'll do the same thing here, right? We're going to add 6 to the x coordinate, and we're going to subtract 3 from the y coordinate. And so we're going to have 6 and -8. Okay, that is the coordinates of the new point or the new image. All right. Our last question here has some context behind it. So a video game, you move a spaceship 1 unit left and 4 units up. Okay. Then you move the spaceship 2 units left. Rewrite the composition as a single transformation. Okay. So let's write these as vectors first. Okay. So 1 unit left and 4 units up as a vector would be, okay, left would be going backwards, so that'd be -1. And up is the positive direction for verticality, so that would be +4. Okay, so going left 1 and 4 units up as a vector would be -1 and +4. Okay. And then the second vector just says, okay, we're going to go 2 units left. Okay, so that's going to be -2 in the horizontal direction and 0 in the vertical direction, right? Because it did not mention any additional vertical change. All right, so altogether, how far horizontally have we moved? Well, we moved 1 unit to the left and then 2 more units to the left. So in total, that's -3, right? So all we're going to do is sum these 2 horizontal components to get an overall horizontal component, and then sum the 2 vertical components to get kind of an overall. Okay. All right, so to write this as one single vector, we could have simply said, all right, move the spaceship 3 units to the left and 4 units up, right? That is the same as performing this translation followed by this translation. You just combine them into one. Okay, so this is a vector form, but we can also write it as a rule. So we can write, take any set of coordinates x and y, and then we're going to subtract 3 from the x coordinate. And the rule for the y coordinate is to add 4. So this is kind of a vector representation of the translation. And this is like a rule representation of that same translation.